In this video, we are going to solve trigonometric integrals with products and powers of cotangent. Now, before we proceed, I want to remind you that we already know these four facts about integrating cotangent and cosecant, so we might need to use some of those along the way. So I just wanted to remind you what those facts were. So let's talk about how we integrate a power on a cotangent. If the power of the cotangent k is odd, and the odd power is greater than or equal to 3, we are going to need to rewrite the cotangent. We're going to take two of those cotangents off. We are going to then, what's going to happen is we are going to use two of them to replace with the Pythagorean identity, and then we end up getting what you see here. You may have to repeat the process more than once if our k minus 2 term is too large. And I'll show you as we go, and it'll make more sense, I think, as we go. So to integrate the following, note that our power here is a 3, which is going to fit this category. It's odd, and it's greater than or equal to 3. So what are we going to do? Well, remember, we're going to use that Pythagorean. We're going to replace two of our cotangents with its equivalent. That cotangent squared is equal to cosecant squared minus 1. Let's rewrite. And when we rewrite, we end up getting 2 times the quantity of. Now, remember, okay, so technically, we took out 2 of the cotangents. It became cosecant squared minus 1. We already had one of them left over, and that's why if you think about that would be a cotangent times a cosecant squared, a cotangent times negative 1. And so that's why we get what we get there. And that follows this pattern you see here. It went down by 2, cosecant squared. It went down by 2, so that's just one of them. And that's exactly what happened. And technically, it's because of our Pythagorean identity. Okay, so now we've done a little rewrite. Let's think about if we separated that into two pieces, okay? Here, we're going to have to do a u substitution. We know that if we let u equal the cotangent of x, then du dx is equal to negative cosecant squared of x. And this piece was some of that facts that we know from that very first slide, that the integral of the cotangent is equal to the negative natural log of the absolute value of the cosecant of x. So let's put all those pieces together. So let's look what happens. So here we know that the cotangent became u, but we needed that negative there because we didn't have a negative, so we would need to replace the cosecant squared x dx with negative du. So the negative du, the 2 just came along for the ride. You can use the antiderivative, so that would be 1/2 of u squared times that negative and that 2, becoming negative u squared. So that piece becomes negative u squared when u is cotangent of x. Now this piece, the cotangent is negative natural log. So if we have a negative already there, negative 2 times that negative would make it a positive 2, the natural log of the absolute value of the cosecant of x. And then we need to have our plus c since this is an indefinite integral. So our final answer, if you look right here, would be the negative cotangent of x squared plus 2 natural log of the absolute value of the cosecant of x plus c. Now let's look at one where we have an odd power on our cotangent. So we're going to follow the same procedure, but we do have a slightly different u substitution that we need to do. If we take a look at what we have, let's take the 5 out in front. So then that just kind of, we know our final answer. We have to multiply through by 5. We're going to do the same thing we did for the last problem with that cotangent cubed, reduce the power by 2. that's going to be replaced by a cosecant squared minus 1. But in this case, it would be the cotangent of 7x, cosecant squared of 7x minus the cotangent of 7x. Okay. So now let's think about what's our substitutions. What are we going to be doing? Well, this time we're going to let u equal the cotangent of 7x, but watch what happens. So remember, when you take the derivative of the cotangent of 7x, that requires us to use the chain rule. So remember, you would take the derivative of a cotangent is negative cosecant squared. So you do the negative cosecant squared of that stuff, 7x, times the derivative of that stuff, which the derivative of 7x is why there's a 7 there. So we do have to account for that as we go through this process. Now on this one, it requires a substitution also because of that 7x there. You might already know that if you have a constant multiplied by your x, it comes out really nice like that by dividing through by that constant. So you'll see that du would equal 1/7 dx. And so we do have to use some u substitution here. So now that we've got what our u substitution is going to be, let's set up our integrals in terms of u. So here, our cotangent of 7x we know is u, so that's why it's u. The cosecant squared of 7x, that piece there, we have to get rid of the negative 7. That's why we see that negative 1/7. Similar here, we have to get rid of that 7. You see that 1/7, and that's the cotangent of u. We know a rule for that, which is going to help us. So now let's take the integral of these two things in terms of u. So this one would be negative 5/7 times 1/2 u squared. This one, we can use that rule we know about the cotangent, that the cotangent's integral is negative natural log of the absolute value of the cosecant. So if we take all that into play, this piece becomes negative 5/14, the cotangent squared of 7x, plus 5/7, the natural log of the absolute value of the cosecant of 7x. Don't forget your plus c, because this is an indefinite integral. So that is a little bit about how we solve trigonometric integrals with products and powers of cotangent. Thank you so much for watching. Have a great day.